Okay, now let's look at cross product. Cross product is the multiplication of two or more vectors, uh, in which the result of the multiplication is a vector quantity. Okay, in scalar or dot product, the result is a scalar quantity, but in cross product, the resultant is a vector quantity. So in this method, multiplication of two vectors results in a vector quantity. So if you remember in the previous slide, a dot b was equal to ab cos of phi, and here a cross b is equal to ab. A times b is this the magnitude of a times magnitude of b times sine of phi, right? So and the magnitude is written like this, of the cross product. The direction of the resultant vector is always perpendicular to the plane of the vectors that are being multiplied. Means that the vector that is the resultant vector of this cross product will be in the direction that is perpendicular to a and b, and the direction of this is determined by right hand rule method. So if you are multiplying a with b, so you will have to curl your fingers of your right hand from a towards b, and the direction of the thumb will tell you the direction of the resultant vector. I will show you in the next slide. And you remember that the cross product of parallel vectors or anti-parallel vectors is 0. Why? Because the vectors which are parallel to each other have 0 angle, right? So sine of 0 is 0. A cross b is sine of phi. So if a and b are parallel or anti-parallel to each other, the angle between them is either 0 or 180. So sine of 0 and sine of 180 are both 0. So multiply any quantity with 0 will give you 0. So, but if they are perpendicular to each other, means that they have an angle of 90 degrees between each other. So if a and b are perpendicular to each other, their angle is 90, and sine of 90 degrees is 1. So we will be left with a times b, the magnitude of a times magnitude of b. So in this case, it has the maximum magnitude. Magnitude of vector product is maximum when a and b are perpendicular to each other, and the magnitude of vector product is minimum when a and b are parallel or anti-parallel to each other, which is 0. Okay, now let us look how we can find the cross expression for the cross product of two vectors a and b. Since we know the formula, we already know this formula: a cross b is equal to ab sine of phi, where phi is the angle between a and b, and a and this b are the magnitudes of vectors a and b respectively. Since we have seen we already know in from the previous slides that vector a can be represented in terms of its components along x, y, and z axis like this: axi plus ayj plus azk, and vector b is equal to bxi plus byj plus bzk. And we also know that if two vectors are parallel to each other, their cross product is equal to 0. Therefore I cross I, j cross j, and k cross k all are equal to 0. And if two vectors are perpendicular to each other, their magnitude is equal to the magnitude of is equal to the product of the magnitudes of those two vectors, and their direction is perpendicular to both of the vectors which are being multiplied. So for example, if means one term from these is axi cross byj. So this component is along x-axis and this component is along y-axis, right? So we can write it like this: the magnitudes outside and vectors inside. So ax times by in the bracket, vectors are being cross product. So the cross product of I and j should be equal to the product of their magnitudes. So both have magnitude of 1, so 1 times 1 is equal to 1, and the direction should be perpendicular to j, I and j. So what is the direction which is perpendicular to I and j? I is along x-axis, j is along y-axis. So what is perpendicular to I and j? Means since I is along x-axis and j is along y-axis, so the direction which is perpendicular to both is z-axis, right? So the unit vector which is along z-axis is unit vector k. That is why I cross j is equal to k, and our whole expression can be represented like this: vector a cross vector b is equal to aybz minus byaz I plus the second term along j plus third term along k. This is we have found by multiplying all of them together. So wherever the same unit vectors come, like a I cross I, we will get 0, and wherever we are getting different unit vectors, means I cross j and I cross k, or j cross I and j cross k, we will have the magnitude of the components, product of the magnitude of the components times unit vector which is perpendicular to both. So in order to uh, memorize and for easy memory, we use this diagram. This is, remember that this is counterclockwise. So in the counterclockwise, 3 arrows, I goes to j to k. So I cross j will be equal to k, and k cross I will be equal to j, and j cross k will be equal to I. And in the reverse direction, k cross j will be equal to minus I, and j cross I will be equal to minus k, and I cross k will be equal to minus j. Because in this right hand, if you look at this is the right hand rule that I stated 2 slides ago, that if we are taking the cross product of a and b, the direction of the resultant vector will be determined by right hand rule. So if it is a cross b, means from a we will roll our fingers from a towards b, and in this case our thumb will show the direction of the resultant vector, okay, like this. So if, on the other hand, if we are taking cross product b cross a, then we have to flip our hand downwards so that we could curl our fingers from b towards a, and then our thumb will point downwards, right? So it shows that the direction of the resultant vector has been changed to the opposite one. So if this is positive, the other one will be negative. So means if a cross b is upwards, b cross a is downwards. So it is represented like this, that a cross b is equal to minus b cross a. It is not commutative like scalar or dot product. A dot b was equal to b cross a, but a dot b was equal to b dot a, but a cross b is not equal to b cross a. A cross b is equal to minus b cross a. That's all for today. Thank you very much. If you have a problem in understanding any of the concept, you can contact me.